Hello Gators, this is 11-3 Pyramids and Cones, Day 2. I can use the volumes of bright and oblique pyramids and cones to solve problems. Let's take a look at Cavalier's principle again with cones. And it says again, if the heights are the same and the cross sections are the same, and in this case they're all circles, then the volumes are the same. Let's take a look at, again, the comparison between a cone and a cylinder with the same base and the same height. And you can see that it'll take 3 cones to make one cylinder. So a cone is only going to have about exactly a third of the volume. All right, so here's what the formula says. The volume is equal to 1/3 area of the base times the height. Very similar to the pyramid. But the base in a cone is always the same. It's pi r squared, so you don't have to worry about changing. Let's go ahead and do this problem. Again, remember, we have a circle for the base. So I'm going to draw a circle. And the radius is, now it's pointing to the whole length here. So the radius is 2 because it says the whole red length is 4, so half of it would be 2. All right, so let's figure out the area of the base, and the area of the base is a circle, so pi r squared. And if we put the number 2 in there, the area of the base will be 4 pi. Don't go to your calculator, just leave it as 4 pi. The volume is equal to 1/3 area of the base times the height. We have figured out the base is 4 pi. The height is 6. Let's do a little reducing. And now let's multiply our numbers, and that's going to be 8 pi. Now this is an exact answer. This will be meters cubed. If we go ahead and put it in our calculator, 8 pi becomes 25.1 meters cubed. Again, this is exact, this is rounded. Let's go ahead and do it again. Again, we have a circle for our base, and it's very clear that our radius is 6. So the area of the base is pi r squared, which is pi times 6 squared, or 36 pi. Again, don't go to your calculator, just leave it this way. Volume is equal to 1/3 area of the base times the height. The area of the base is 36 pi, and the height is 15. And let's go ahead and reduce. 3 goes into here once, 3 goes into here 5 times, and we'll do 36. I could have reduced with a 36. It doesn't matter where you reduce. And so this answer is going to be 180 pi. Now this is an exact answer. This will be centimeters cubed. If on the final I ask for a rounded answer, then you'll put it in your calculator, and this answer will be 565.5 centimeters cubed. Okay, let's do it again. Let's make this a backwards problem. So we're being asked for the height when we know the volume and we know the radius. So here's the formula. I'm going to write 956 equals 1/3. And the area of the base, remember, it's going to be 81 pi because that radius is 9. And then times what we're looking for, which is h. I'm going to do a little reducing. And 3 goes into here 1 time, 3 goes into here 27 times. So I have 956 equals 27 pi, and then I have my h that I'm looking for. Okay, now to get h by itself, I'm going to divide both sides by 27 pi, and you're going to have to be very careful when you put this in your calculator and make sure your calculator knows that the pi is in the denominator. So make sure you practice doing this. And so this is 956 divided by, and this is going to be 27 pi. Check yourself, and the answer rounded to the nearest tenth is 11.3, and our label will be feet. It's not cubic feet because it's just a height. All right, let's go ahead and do it again. This time, volume is equal to 1/3 area of the base times the height. 7,200 equals 1/3. And then our radius is 15, so that'll be pi r squared, 225 pi, and then times h. All right, and so we have 7,200 equals, now there's no reduce, oh yes we can reduce here. Okay, let me try to reduce. 225 divided by 3. Okay, so this is 1 and this is a 75. So now we have 75 pi and we're looking for our h, which means we have to divide both sides by 75 pi. And again, make sure you are using your fraction template so that the calculator knows the pi has to go in the denominator. And this is 7,200 divided by 75 pi. And I'm getting 30.6, and this will be labeled yards. It's a linear measurement. Okay, last problem, which is a composite. We have a cylinder and a cone. So the cylinder will be area of the base times the height. And this whole thing is a diameter. So the radius will be from here to here, and that'll be a 3. So this will be 9 pi r squared. So this is 9 pi, and the height is 50. So this will be 450 pi. Now the cone will be 1/3 area of the base times the height. Now the base is the same as the cylinder, so this will still be 9 pi. And the height is, we don't know. We don't have a height. So let me go ahead and draw one. So that's my height. This is a 5, and this is a right angle. So I'm going to have to use the Pythagorean theorem, which is 3 squared plus h squared equals 5 squared. So that's 9 plus h squared equals 25. H squared will be equal to 16. So that tells me h will be equal to 4. So that's a 4. And so that's the height of my cone. So this will be a 4 right here. Do a little bit of reducing, and this answer is 12 pi. So this is 450 pi for the cylinder, and I had to do a little bit more work on the cone, 12 pi, and so that answer is 462 pi, and this is cubic meters. Now it doesn't say to do it in tenths, so I'm going to just leave it exact. And this is the end of the screencast.